Let's explore C++ sets. Sets are ordered containers that store unique elements. In this lesson, we will cover the C++ standard template library implementation, known as standard: set. A C++ set is a powerful container that stores only unique elements, automatically maintains these elements in assorted order, provides logarithmic time complexity for most operations, and is implemented as a balanced binary search tree. This ensures efficient searching, insertion, and deletion. Let's look at some basic set operations in C++. First, include the necessary headers iostream and set. Inside the main function, create a set of integers using the syntax standard: set, angle bracket int, angle bracket, then give your set a name. You can insert elements into the set using the insert method. For example, numbers.insert 10, numbers.insert 5, numbers.insert 20. The elements are automatically sorted upon insertion, and any duplicate insertions will simply be ignored. This code demonstrates how to create a set of integers and insert elements into it. Now, let's explore how to access and iterate through the elements of a C++ set. Start by creating a set of integers, for example 5, 10, 15, and 20. To find a specific element, use the find method, such as numbers.find10. This returns an iterator to the element if it exists, or numbers.end if the element is not found. You can then check if the element was found and print its value. To iterate through all elements in the set, you can use a range base for loop. This allows you to easily access each element in the set. This code demonstrates how to find elements in a set and iterate through its elements. Next, let's discuss how to modify sets in C++. Consider a set of integers 5, 10, 15, and 20. When inserting elements, the insert method returns a pair. The first element of the pair is an iterator to the newly inserted element, and the second element is a Boolean value indicating whether the insertion was successful. You can erase elements from the set using the erase method, either by providing the value to be erased, such as numbers.erase10, or by providing an iterator to the element to be erased. If you have an iterator, you can call the erase method by passing the iterator of the element you want to erase. These modification operations allow you to easily insert and remove elements from a set. Note that iterators to erased elements become invalid, but other iterators remain valid. Let's explore some key properties and performance characteristics of C++ sets. Start with an example set of integers 5, 10, 15, and 20. You can obtain the size of the set using the size method, and check if the set is empty using the empty method. To check if an element exists, you can use the count method or the find method. The count method returns the number of elements with a specified value, which will be 1 if the element exists and 0 otherwise. The find method returns an iterator to the element if it exists, or numbers.end if the element is not found. The lower bound and upper bound methods can be used to find the range of elements within a certain range. Sets offer logarithmic time complexity, that is, big O of log n, for search, insert, and erase operations, maintain elements in sorted order, ensure uniqueness, and are typically implemented as self-balancing binary search trees such as red-black trees. Now, let's discuss how to use custom comparators with C++ sets to change the sorting behavior. By default, sets use standard : less angle bracket greater than for ordering, but you can provide your own comparator. To create a custom comparator, define a structure or class with an overloaded function call operator. For example, create a struct called descending order with an overloaded function call operator that compares two integers and returns true if the first is greater than the second. To use this custom comparator, declare a set with the second template parameter set to your custom comparator type. When you insert elements into the set, they will be sorted according to your custom comparator. This code demonstrates how to create and use a custom comparator to sort elements in descending order. Once a set is created, its ordering cannot be changed. The comparator affects how elements are stored and retrieved. Now let's see how to use sets with custom objects in C++. When using custom objects in sets, the objects must be comparable. There are two main approaches. The first is to overload the less than operator within the custom objects class or struct. For example, in a struct called person that has a name and age, you can overload the less than operator to compare person objects based on their age. The second approach is to provide a custom comparator. For example, create a struct called personNameComp with an overloaded function call operator that compares two person objects based on their names. You can then declare a set that sorts the objects by name by passing the custom comparator struct. It is important to avoid modifying a key property used in comparison, as this will corrupt the set's internal structure. So be careful while choosing sorting parameter. Let's explore several set operations available in C++. Given two sets, you can perform operations like union, intersection, and difference using standard algorithms. The set union operation combines all unique elements from both sets into a single set. This can be achieved using standard : set union, providing the beginning and end iterators of both sets, and an inserter for the result set. Similarly, you can find the intersection, difference, and symmetric difference of two sets using standard : set intersection, standard : set difference, and standard : set symmetric difference, respectively. Each of these functions requires similar arguments: the beginning and end iterators of the input sets, and an inserter for the result set. These operations enable powerful set manipulations in C++. Let's discuss some best practices and alternatives for using C++ sets. Use standard : set when you need a collection of unique elements with fast lookup, insertion, and deletion, all while maintaining sorted order. Avoid modifying elements in a way that would affect their ordering, as this can corrupt the set's internal structure. Use count or find for checking existence, not a manual loop through elements. Use the hint version of insert when inserting elements in order for better performance. As alternatives, consider standard : unordered set when order doesn't matter, as it offers O of 1 average time complexity for operations. Standard : multiset allows duplicate elements while maintaining sorted order. Standard : map is useful when you need key value pairs instead of just values. Finally, standard : vector plus standard : sort can provide better cache locality when you rarely modify the collection. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.